Dear students, today we'll see what do we mean by transmission medium. Now, transmission medium is a path between transmitter and receiver over which the message or data or information is transferred. So, between transmitter and receiver, whenever the data is going to travel, whenever the message or the information is going to travel from transmitter to receiver, it uses transmission medium. So that path between transmitter and receiver in which the data will travel from transmitter to receiver is called as transmission medium. Transmission medium can be classified as guided media or unguided media. So in a guided media, it is called as wired. So here you can see transmission media can be classified as guided media or it is wired, and it can also be classified as unguided media or wireless. So either it is a guided media with a physical wire or something, or it is unguided media where it is open space. In a guided media, we can have twisted pair cable as the simplest one, where the two wires will be twisted. Then we can have coaxial cable. Then we can have fiber optic cable in which light can travel. So these are the main three types of a guided media or wired media. Similarly, you can have unguided media where air acts as medium. You can have in that microwave links, or you can have infrared rays which can travel, which can take your data from transmitter to receiver. So this is the classification of a transmission media. Now one by one we will see what do we mean by a guided media and what are the types of those guided media. But dear students, next we'll start with the first guided media, which is called as twisted pair cable. Now in that we are having subdivision, and in that subdivision the first one is called as unshielded twisted pair UTP, and the second one is called as shielded twisted pair STP. Now in unshielded twisted pair, you can see a pair of wires which are twisted among each other. So here you can see a twist, here you can see a twist, here you can see a twist. So the pair of wires is made up of copper conductors innerly. These are copper conductors which are internal, and upon that you are having polyvinyl chloride insulation. Polyvinyl chloride insulation. Okay. Now here, when it is twisted, that means each wire is exposed to the outside interference equally. Each wire can pick up outside interference unwanted signals equally. They are exposed to outside interference equally. So they are equally exposed. That is why that twist will come into use. Now this type of cable is mainly used when you want to transfer or transmit differential voltage. Differential voltage means where output voltage will be equal to subtraction of the input voltage, V1 minus V2. See, V1 is applied to one wire and V2 is applied to another wire. Okay. Now when the signal is traveling, that voltage is traveling, it will get added with noise. So here you can see the first V1 will be V1 plus voltage of the noise, and the second V2 will be V2 plus voltage of the noise. If you take the subtraction of them, okay, so V out will be equal to V1 plus Vn minus V2 plus Vn. If you take this, it will be V1 plus Vn minus V2 minus Vn. Okay, so Vn will go, and what will remain is, this is V1, what will remain is V1 minus V2. So V0 will be equal to V1 minus V2. So the noise voltage will get cancelled out. The noise voltage will get cancelled out because you have twisted the pair of cables. Okay, and this type of cables are light in weight and they are also very easy to install. Installation of this also is very easy. Now here students, in the second type of twisted pair, we'll see what is shielded twisted pair, STP cable. So the second type is called as STP cable, shielded twisted pair. It is having the same type of twisted cable which is covered by a metal shield. This is important. The twisted pair cable is covered by a metal shield, and these wires are having inside copper conductors, and that set of twisted pair is covered by a metal shield. Now this metal shield will prevent any outside electromagnetic interference. It will not affect the signal passing through this cable, and it will also reduce any type of radiation from this outside. So it is going to prevent your electromagnetic interference from outside. So this metal shield is going to do that work. And upon all this assembly, you are having a plastic cover on top of it. So STP is a twisted pair cable which is covered by a metal shield, which is very important. And upon that, you are having a plastic cover. No doubt it will be a little expensive than the UTP, but it has prevention for electromagnetic interference. So electromagnetic interference from outside world will not affect the signal passing through this cable. Okay, so this is your STP cable. Dear students, now we will see the second type of a guided media, which is called as coaxial cable. Now in this coaxial cable, the innermost conductor will be a copper core. This is the inner conductor. Inner conductor in which the main signal will be propagating. So this is your inner conductor. Upon that inner conductor, you are having a insulating material which can be Teflon. Upon the insulating material, you are having one more conductor which is called as wire mesh. This is your wire mesh. It is a mesh of wire. So this is one more conductor. And upon that, you are having protective plastic covering. Okay. Now here, the innermost conductor and this wire mesh are the two conductors available. And both the conductors share the same axis. So if you take the axis of the cable, if this is the axis of the cable, so the inner conductor and the wire mesh both are sharing the same axis. That is why they are called as coaxial cable. They are called as coaxial because both the conductors will share the same axis. They are concentric towards the same axis. And second thing is, because you are having this wire mesh conductor, there will be no electromagnetic. That means electromagnetic interference from outside world will be minimized a lot. So there will be no electromagnetic interference from outside world. It will be minimized a lot. So it is protected. Your signal which is passing, which is traveling through this cable, is protected from outside electromagnetic interference. Therefore, this can be used in telephone lines. This can be used in your computer networks. This can be used in baseband transmissions like Ethernet with CS/MSCD. So all these applications make this coaxial cable more important cable for transmission. Dear students, now we will see an optical fiber. Now optical fiber is a fiber made up of glass or plastic which can carry light energy, light ray from one end to another end. That is from, you can call, transmitter to receiver. Okay. Now optical fiber, the innermost core layer, the innermost arrangement is called as core layer. The core layer is very important here because light is going to propagate through core layer. And upon that, you are having something called as cladding layer. Core and cladding can be made up of glass or plastic. Core also can be made up of glass or plastic. Cladding also can be made up of glass or plastic. And upon all this arrangement, you are having a protective plastic layer which is called as jacket. Okay, now when light rays follow through it, when light rays enter the core, it should follow something called as total internal reflection. That is, light should travel like this in the core only, and that is why whenever we manufacture optical fiber and the material used for core, whether it is glass or plastic, and the material used for cladding, whether it is glass or plastic, we have to check the refractive indices of both. The refractive index of the core material should be more than the refractive index of the cladding material. If you maintain this condition, then only whatever light enters the core will follow or will propagate with total internal reflection. It will go with total internal reflection. This is the core inside. So light will go with total internal reflection. It will not come out and get mixed into the cladding, because you have maintained that refractive index of core material is more than the refractive index of cladding material. Now, because of this, what will happen is, if you are having many fibers together, so the light traveling in one fiber will not interfere with light traveling in the adjacent fiber because of this condition. So this is your optical fiber in which light is going to carry your data, message or information, and light is going to propagate with the phenomena of total internal reflection. And to maintain that total internal reflection, the refractive index of the core material should be more than the refractive index of the cladding material, whatever you use, whether it is glass or plastic. So this is your basic optical fiber construction.